everybody, Mr. Rubo here. Today we're actually going to do topics 1.9 and 110. They're both rational functions, but we combine them because it's vertical asymptotes and holes, and they are very closely related. So, little recall here, you can read that yourself. But again, it's just the idea that a rational function is two polynomials divided. But the thing that we're most focusing on is when the denominator is 0. Okay, it's not able to happen. When that happens, graphically, what we get are either vertical asymptotes or holes. Okay, and we'll talk about when do we get one. When do we get each one? So the first one, a hole, occurs when the factor in the denominator cancels out with factors in the numerator. Okay, so if you have a factor in the numerator, factor in the denominator, cancel, you have a hole. A vertical asymptote occurs when a factor in the denominator doesn't cancel out, or cannot cancel out with a factor in the numerator. So in other words, you simplify the rational function, and it still has a factor in the denominator. That's going to tell you your vertical asymptote. So you can kind of see here a couple examples. So here, x minus 1, if we kind of see that, we see that it's in both. Same with g of x, x minus 1. It has that cancel. We would consider it would have a hole. Technically, g of x is a special case, which we'll talk about later. If you look at the equations over here, nothing gets canceled, okay, except, so nothing gets canceled, which means our denominator is x minus 1. And now for this one, this is actually kind of similar to that last example. We get something that cancel, but this x minus 1 is still in the denominator, so we actually have a vertical asymptote at 1. If it ever happens where you have both, so in g of x in both of these cases, if that happens, vertical asymptotes beat out holes. Okay, so they are always going to be what you would graph. You don't graph both things, you just graph the vertical asymptote. Okay, so if we look graphically, here's our hole. You can kind of see it's an open circle. I'll kind of zoom in a little bit on the graph. That's how we represent a hole. We literally draw a hole. Okay. Vertical asymptotes, on the other hand, we use these dashed lines. So you can see here, we actually have vertical asymptotes in both of these. So what we're going to notice, though, is our limit. Okay, so we're going to talk about the limit as x approaches 1 from the left. When we're talking this hole, the limit is from the left side as we're kind of approaching, it's 3, and the limit from the right side as we approach that x equals 1 is 3. So they will always be the same if it's a hole. Okay. As far as vertical asymptotes go, though, these are where you're going to talk about going towards either infinity or negative infinity. Here we can see from the left side, we are going to negative infinity, right? We're going straight down, where from the right side, we're actually going to positive infinity. Okay. Now, these could be the same. It is possible for that to happen. They both could be infinities, both be negative infinities, but vertical asymptotes will always be infinities when we do the limits. As far as holes will be, they will be specific values. Okay. So yeah, thanks for watching, everybody, and have a good day.